All right, everybody, welcome in. ME 490 Senior Design Seminar. Let's go. Today, we have a very, very special guest speaker, me. Yes. Today, I'll be talking about codes and standards and also about graduate school. Interestingly, last year's seniors, they took a senior design exit survey and they're asked all sorts of crazy questions. One of the questions they're asked about is, did you feel comfortable or do you feel like you got enough information about graduate school to really know what graduate school is and all these sorts of things? And the average answer was like 2 out of 5. So it seems like there's a want or a need from the seniors to learn about graduate school, and that's what you're going to get from me today, at least in part. First thing we're going to start with today, though, is a discussion on codes and standards. I don't think it's going to take all that long to get into codes and standards. We'll just kind of define what they are, why they might be useful for your design, where you might find them, which ones might be applicable for you, all those sorts of stuff. And then we'll get into grad school. What is the power of your current degree, whether or not grad school might be a good thing for you, what are timelines for graduate school, how much does it cost, all those sorts of good things, and then whether or not I think you should do it. My own personal recommendation at the end of the talk today. All right, so without further ado, let's get into it. First things first, we'll do the codes and standards. So slides for this talk that I'm about to give, you can find on sort of the folder for the team in the Microsoft Teams sort of group folder there. Okay, so let us do this thing. Okay, here we are, codes and standards. Let me share the other. I want to share this screen. How about this? There we go. All right, here we are. So you all should be able to see codes and standards up on your screen now. Right, so codes and standards. Why are they useful in your design? Okay, well, they're really used in your designs to make sure that your products are safe and meet some sort of specification. And really where you're going to go mostly to find your codes and standards for your applicable design will be to the MSOE library. So we had a presentation from the MSOE librarian last week that, kind of showed you all the information and resources that the library has. And one thing that the library does offer is a pretty good database for codes and standards. They don't have all of them because codes and standards actually cost money to obtain and to keep current. So they don't have a lot, but specifically for MEs, I think they do a pretty good job. So let's put some definitions to this and talk about what they actually are. So a code is in a standard, they're not the same thing. They often get lumped together, but they're really unique entities, okay? And specifically, a code is like a set of laws or rules that is governed by a municipality. So your city, your state, the federal government, etc. And codes actually can carry the penalty of law. So I kind of underline that for that specific purpose. So the idea here is that if you design something and it's supposed to adhere to some code, which is your city code, maybe the city of Milwaukee has some code for fire extinguishers, okay? If you design a fire extinguisher and you're going to use it or sell it and it doesn't adhere to a code, you could be punished a lot of money for having that fire extinguisher in your building or whatever because it's not up to code. All right, or you could get shut down, your business could get shut down, etc. Right? So the main purpose of these codes is to protect the public. That's what you should be really thinking of when you're thinking of codes. They're actual laws that protect the public, and you have to adhere to them if you're designing stuff. There you go. There's a code. A standard is doesn't carry any power of law. A standard is just kind of like an established technique or norm. For example, how many threads go on a 1/4-inch diameter bolt? All right, there's usually a 1/4 20 and a 1/4 28 option. All right, that would be 20 threads per inch or 28 threads per inch. Those are sort of standardized bolt sizes that people have generally come to use and understand. And so there are documents that sort of detail, okay, if you're going to have a 1/4 20 bolt, this is like the standard size and how we make it and all these sorts of things. And that can be particularly useful because let's say I have some design that I'm making. If I say, all right, I got this bolt that adheres to this particular standard, well, there's probably a zillion suppliers out there that say, okay, I can give you this standardized bolt, right? It makes your design cheaper. It makes it more reliable because you understand that it's the standard part that you're using, and so on and so forth. Okay, so it really ensures, like, if you say my design adheres to this standard, or I'm using the standard bolt, or my material meets this standard specification, it really helps give clarity to all the requirements that are inherent to the design that you've made. All right, so that's the difference between codes and standards. A standard does not carry the power of law, but the code, rawr, definitely does. All right, here's an example of a code. I pulled this from the National Fire Protection Association fire code. So here's code number 1 of this particular fire code. It's municipal fire code. And so they have this sort of preamble here, kind of on the left-hand side. And this code here is actually 75 chapters long, which to me is just like absolute insanity. And so you can kind of go to the table of contents and look at, all right, chapter 60 is the chapter that's devoted entirely to codes for handling hazardous materials inside of my building. Okay, and so let's say we zoom in a little bit more and look at section 60.1.4.3. All right, sure. If your facility happens to temporarily be out of service, you have to continue to maintain a permit and be monitored and inspected. Okay, so this is just one very specific code in this whole entire fire code that details if you happen to temporarily go out of business, you still have to maintain like a hazardous waste plan. All right, and that would be like a code. Maybe that's not necessarily part of an engineering design, but you get the general idea here that it's a very specific item that if you did not adhere to, you could be punished by law. Rawr. Okay, so this is one particular chapter detailing codes associated with handling hazardous materials, but there are other types of codes that might exist for like building fire extinguishers, let's say. All right. Where you might find these codes, again, is the library. So the MSOE library, their search database is really quite good. The website is there. Go to that website. Please take a look at that, okay? Since the codes are generally not free to unveil them to you, using the library resource is best because they have a lot of paid access to a lot of codes already. So you don't necessarily have to pay for them yourself unless you want some obscure code like, you know, what are the electrical outlet requirements in Germany? And, you know, probably that code you can probably access through MSOE. So maybe that one's not so obscure. But what are the building requirements for rebar in Russia? Okay, well maybe that one you don't have access to, and you gotta buy that and maybe translate it. Yeah, so that's one resource. Books. Okay, I know there are these like physical things with pages of information that you can hold in your hand and flip them through. I mean, I know books are kind of going out of style, but you know, most of these codes are contained in books. So one example would be the National Electrical Code, which would have all sorts of information about like EMI shielding, battery requirements, battery sizings, heat generation for electronic devices, all the codes associated with that, right? So there you go. You can get it on Amazon. There it is, kind of on the lower right-hand side here. Okay. Otherwise, you could just go to the internet and start searching for stuff. Like, there are many codes which are applicable for welds. So if your design is going to use welds in any way, you probably want to start paging through the AWS standards or AWS codes, which is the American Welding Society. So if you're going to weld something together, you need to be able to specify this is the weld that I want, and this weld will adhere to this particular code. All right, this is an important one. So that's an idea of codes. Some questions that you might see commonly for codes. How do I know what codes are applicable to my design? That's a hard one because each of the designs that you guys have for your particular projects are going to be different. And so someone that's using a lot of batteries for their design because they have something that requires a high amount of power, they're going to probably want to dig in on some like electrical codes that are more important for them. Okay, so like what's the maximum amperage we can pull from this thing safely before we are violating some code about this handheld device. Okay, that might be one example. All right, so you might consider asking your advisors like, hey, we're designing this air freshener spraying device. All right, well, there's probably some codes associated with the amount of air pressure that you can have on the inside of that, you know, aerosol can. I'm sure that there are. Okay, so you just might want to ask around and depending on your particular project, what codes might be applicable. All right. Then another commonly asked question is, what designs are most driven by codes? So what I mean by that is, okay, well, maybe one group is working on HVAC design, all right, designing some HVAC component. Okay, well, that HVAC component is going to be used in some public environment, and so codes are going to be very important for that HVAC design. How much airflow is going through there is probably governed by some code. How much back pressure are you allowed on your filter? Probably governed by some code. So these things are important because if you're not filtering the air properly, if you're not pushing as much air through as you think, you're going to affect the air quality of the room, which is a potential harm for the public. All right, so designs that are most useful or most frequently going to use codes are designs where the public is generally directly impacted. Anything using concrete, anything that you can think of basically that uses concrete probably has some codes associated. You know, codes for how much rebar you can incorporate in that concrete if you're going to have rebar reinforced concrete. All these things, all right, many things, but basically it comes down to what degree will your design be used by the general public? The more likely it is to be used by the general public, the more influential codes will be for you. All right, continuing. Standards. Remember, standards are generally accepted sort of norms for engineering design. And standards can range in all sorts of different areas, okay? Standards can be things like standardizing how materials are tested, okay? Standardizing how materials are manufactured, standardizing tensile strength of bolts, standardizing all sorts of stuff. These aren't necessarily laws or codes which you have to adhere to, like, you know, previously what we talked about for codes, but standards are so helpful and useful in your design because the more that you use them and the more that you employ them, the less liability you're going to have, the less digging around you're going to have to do to find, all right, what specific bolt do I need or whatever. If you just say it adheres to the standard, away you go. Okay. Here's one example of an ASTM standard. This is ASTM standard D7250. It's a standard that specifies how that you can determine a sandwich beam flexural and shear stiffness. So if you're interested in, let's say, designing an aircraft wing that happens to be a sandwich structure, let's say you're designing a UAV and you have a foam core, carbon fiber skin, face sheet, sandwich composite. And you're like, man, it would be nice to know the flexural stiffness of this particular guy. Uh-oh. I hear someone. Can you please mute your microphone unless you have a question? Okay, say you want to know the shear. Okay, so go pick up the standard and make some test coupons and test it. That will give you the values that you desire. So here's some excerpts from this particular standard. It tells you this is what the sample geometry should look like if you want to test for the beam flexural stiffness. Here's the analysis that you can do. They give you the equations. It's amazing. They don't derive them. They just give them to you. That's what you've always wanted. You never want us to derive the equations. You just want us to give them to you. Well, here you go. The equations are given to you in the standard. No derivations. All right? So there you go. Standards for example testing materials, but others exist as well, like sizing of bolts, or how do you make a steel alloy, or whatever. You know, there's lots of different standards that exist. Where you might go to find these standards, again, get thee to the library search. All right. The library here actually has a pretty large wealth of these standards, and that's because they're actually quite useful for us as design engineers. So here, for instance, you see the library has full access to volume blah, 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 3.01 about metals. So if you're doing anything metals related, maybe dig through some of the standards and say, oh, here's the standard for aluminum 6061. And so you call out, all right, this portion of my design must be aluminum 61 adhering to ASTM B3.1. Bang, there you go. That way, anyone that looks at your design in the future just says, all right, as long as I get an aluminum that adheres to this particular standard, I'm good to go, right? There you go. Some other things, high and low temperature testing, metallography, etc. Those are things that the library has access to. IEEE standards, these are all things electronics related. So what's a standard outlet look like? How much amperage, voltage, what's the hertz, you know, the frequency coming out of that outlet, etc. All that information available through the library standards. So do that. Here's an example of something that you might come across. And I was just kind of perusing McMaster-Carr, the best website for paying 3 times as much as possible for every single item. If anyone's purchased anything off McMaster-Carr, you can get things much more cheaply, but McMaster-Carr is the best for quick delivery. Anyway, often you're going to want to use standards to adhere to certain codes. And so let's take a look at this particular bolt. Let's say I want to buy a bolt from McMaster. Okay, well, I can just buy some standard socket head cap screw and not worry about any of the specifications associated and probably use that in my design. But let's say I wanted to use my bolt in some aerospace application, and that aerospace application by code calls for a bolt that adheres to NAS 1352. Okay, well, if I purchase a bolt and I know that that bolt has been standardized to NAS 1352, away I go. So I get myself to McMaster and I look at, okay, if I'm going to purchase this bolt, here is a standard which it adheres to in terms of its particular sizing according to NAS 1352. Okay, there you go, right there, bang. So I can use this information to say, if I get this bolt, I know that this bolt is a standardized bolt according to that particular standard, and I don't have to worry about testing its tensile strength or testing its, thread counts per inch or whether or not it's going to fit into the hole that I tap. It's all been standardized. You already know that, okay? So if it's a standard piece or standard part and it adheres to this, away you go. You don't have to think about it. Your life is easy, okay? So here are these standards which this guy particularly adheres to, and here are the 2 associated standards. You can look these up. You can get them for free online. I just did like a basic internet search for these 2 things, and up they popped. Both of these standards are associated with the size of that bolt for whatever particular application, it might be used for. So here, this National Aerospace Standard provides standard requirements for bolts to be used in aerospace applications. So if you're designing a UAV, you're designing some small satellite, you're designing whatever the case may be, and that thing is going to be examined to make sure it adheres to a set of codes. If you just say, all right, all my bolts are standardized NAS 1352, then you passed your code check. You know what I mean? So it's just a very useful idea here. Same thing with this MS 16997. This is a military specification standard. Again, telling you exactly what size it is and sort of whether or not it's standardized to fit into, whatever size application you're going to use. Okay, so those are some examples. Questions about standards. How do I know which ones are applicable to my design? Again, because it's not like a coded system, right? So codes and standards are different. Standards, you can basically make a design without adhering to any standard. Not advised, but could be done. So I'll say that there aren't really any hard set of rules on how standards really apply to your design, but the more standards you utilize, then the easier your life will be, okay? Because if you use some non-standard material that you just don't know anything about, how do you know if your design is going to hold up to the stresses that your design requires? If you have a standardized aluminum that adheres to, ASTM B3.01, you say, all right, I know my tensile strength of this is at least X value. So if I design my design to twice that, then I got a 2 times safety factor based on a standardized tensile strength of this aluminum member that adheres to ASTM blah. All right. So that's going to help you. All right. So my question there then is, can I create a design without using standardized components and materials? Well, yes, you could, but why would you want to do that? Like, why would you use some random non-standardized part when you could just use a standard thing, right? Like, let's say I want to make a design and I want to build something, and my design is going to be unique, all right, because I'm a unique flower, all right? And so instead of quarter 20 bolts, I'm going to use quarter 19 bolts because I said so. All right, well, great. You got to find somebody to manufacture that for you. It's not very standardized part. I would say it's a non-standard part. So you've got to find someone. You've got to pay them an exorbitant amount of money. You have to test to make sure that the strength of that bolt is what it is. It's such a headache. Just buy a standard bolt and use a standard bolt, right? It's a very simple, example, but there are many other situations where this exists, right? Like, there are commercial off-the-shelf components that are standardized, like a transformer that you plug into the wall to transform from AC power to DC power. Okay, there are many off-the-shelf components that you can buy for this transformation of power. So buy one that adheres to some certain standard and call that out in your design. That the transformer here that we use adheres to IEEE XXXXX. All right, so you're using a standardized piece that someone else, if they need to modify your design in the future, can understand. All right, so there you go. Standards, yes, good things. Now, wrapping it up for codes and standards, here, remember what they are. Codes are municipal laws that keep people safe. So you have to adhere to them, especially if you're using them for like a general purpose or for the general public. Standards are norms which are generally accepted. Okay, so it's not like by law that you have to use them, but if you use them, your life will be easier. Sometimes the use of standards are required by codes. So you might see a code that says must use bolt that adheres to ANSI blah, right? So you might see that. So you have to know the difference and understand where to go to identify those two things. Finally, standardizing as much about your design can really help you. So the more standards you can specify for whatever you're doing, your HVAC system, your chassis for your formula vehicle, whatever, all right, the more you can standardize about it, the better, because it'll help you find and replace components. Let's say my supplier for my bolts all of a sudden shuts down for whatever reason. Okay, well, now I need a new supplier for my bolt. Well, if I just say, hey, you over here, can you make me an ANSI, specification bolt that gives me this? They say, sure. And they send it to you, and away you go. You got a new supplier, no problem. All right, it can help you that way. It can help you reduce liability if you just specify all of these bolts. They adhere to this particular standard, so I'm good, right? Etc. So you get the general idea. Use standards, call out your standards, specify standards in your designs. Any questions about codes and standards? Where's my teams? There you all are. Alex is growing flowers. Professors have known we don't want to derive equations all along. Yes, we know, but we force feed them to you, and you like it. All right, so if there's no questions about that, let's talk about grad school. Bam. Next topic. All right, and this is sort of where I'll take the rest or the remainder of the time for this. Graduate school. I don't think MSOE does a great job kind of telling you guys or teaching you guys about graduate school. And why does this keep like... I got to figure this out. Hold on. All right, there. You should see it. Personally, I don't think MSOE does a very good job advertising and talking about graduate school with its students. I think that's traditionally because MSOE is, by its own history, sort of been imbued in the Milwaukee blue collar industry to produce engineers that work in local companies. But as sort of the world has evolved, MSOE is now delivering engineers not just locally to the Midwest, but because of the ease of transport all around the world. And so kind of the ingrained culture of MSOE in the past has been we make engineers for the local Wisconsin community, and generally that idea has been, we're not making graduate level engineers, we're making blue collar, raw, let's design cars and stuff sort of engineers, which is great. I got no problem with that, okay? So I'm not trying to like bash just getting an undergrad degree. That's far from what I'm trying to do here. But I'm trying to give you information about graduate school because I think traditionally MSOE hasn't done a very good job explaining what it is, what you should expect, why you should or shouldn't go to graduate school, and so on. All right. So I will tell you this, in my personal opinion, if you're going to graduate from MSOE with an ME degree, you are smart enough to go to graduate school in engineering. Personally, I think the MSOE curriculum is quite demanding, more so than other schools. Let me give you an example. I went to Madison for my undergrad. Okay, I would put the best engineers at MSOE against the best engineers at Madison, hands down. I think it would be equal. But I think of the lowest level graduates coming out of Madison against quote unquote the lowest level graduates coming out of MSOE. The MSOE grads would crush the Madison low level graduates coming out of there. Okay. I think if you make it through the ME program at MSOE, you are superior to some of the other schools. Let's just say that. I saw a lot of people slacking off at Madison that I can't believe they have engineering degrees. Okay, it makes me scared. Okay, but I feel much more confident in anyone getting a degree from here. Let's say that. So my point is that if you make it through the MSOE curriculum and get an ME degree, you have the ability to go to graduate school and get a graduate degree. The question is it the right choice for you, and do you want to do it? So I want to give an introduction here and talk about that. So as seniors, you might be thinking about graduate school, but you haven't really given a lot of information. So what I want to do in this next, 15 minutes is answer questions like, what grades do I need? How much does it cost? How much more do you get paid if you go to graduate school? How is your day-to-day life going to change if you get that grad degree? What's the process? How long does it take for a master's versus a PhD? What's the difference between a thesis and a non-thesis master's, etc.? My focus here for this talk is really going to be on a graduate degree in engineering, but I will make some discussions about some other types of degrees that are common for engineering undergrads to go into as well. Things like a master's in business administration, MBA, a Juris Doctor, which is like the law degree, and so on. Okay. Before we get into why you may or may not want to go to graduate school, you have to understand the power of your undergraduate degree first. Okay. There are a variety of resources that allow you to compare your ME undergraduate degree to other degrees that you might see. And, chuckles aside, the ME degree is very, very powerful. Here, this is information from just payscale.com, which is some website that accrues a bunch of this information. It says your entry-level salary is above average for all college majors and below average for engineering majors. That's just the nature of the ME degree. Your meaning score for an ME undergraduate degree is 51%. Now let's define meaning score. Meaning score is like how much you feel that your degree is contributing to society. So if you're a mechanical engineer, your general feeling of the meaning of your degree is about average contribution to society, about average, which is fine. Compare that to some other degrees that you might see like in the healthcare field, doctor, nurse practitioner, physician's assistant, physical therapist, occupational therapist. Those sorts of jobs generally have a much higher meaning score. Okay, so I'll just give you a general feel there. Those are in 80 to 85%. Interestingly, garbage man, quite high. So don't necessarily correlate how much money you're making with your meaning score. It's not really necessarily the same. Okay, so there you go. This is from the Bureau of Labor Statistics, bls.gov. This is, again, a great resource. People look at the statistics for all undergraduate degrees, and here you go. Median pay for mechanical engineers, $88,000, terrific amount of money. This is, I would say, early to mid-career, something like that. There are many, many jobs available, well above average. But one drawback of a mechanical engineering degree is that the field is not particularly growing quickly. So the field is growing at a rate of about 4%. And they list here about as fast as average, but that's not quite true. It's actually slightly below average. Compare this to healthcare fields, where if you're getting nursing degree, the rate of growth of that particular degree is anywhere from 20 to 25%, depending on the statistics you look at. So while it doesn't really look like it means a lot on the front end, what you want to consider when you're thinking about the potential job growth for mechanical engineers is how much negotiating power you might have in the future to negotiate things like salary and benefits and those sorts of things. If your field is growing at a tremendous rate, like nurses, nurse practitioners, etc., then you have a lot more bargaining power to negotiate for higher salaries in the future when you're in higher demand. But mechanical engineers, we're growing about as fast as average if you get a bachelor's degree, or maybe slightly below average, so you won't have that same bargaining power that maybe someone with a degree that's growing much, much more quickly might have. Computer science grows very, very quickly. So it's not really a benefit or a drawback. It's just something I think you should sort of understand. All right. Where you might go with your job if you get a bachelor's degree. This is sort of a depiction of what careers you funnel yourself into with a mechanical engineering undergraduate degree. Obviously, the most common is to become a senior mechanical engineer at some company. So later on in your life, you get promoted into a senior mechanical engineering position. That's just the most common result. But other things can happen too. You can become a project engineer or design engineer. I would say these are generally the same sorts of things. Generally, job satisfaction, very good. 3.7 out of 5, pretty good. Couple of other benefits and drawbacks to your bachelor's degree. You're going to have an above average salary. You have many jobs available to you across many fields. Think of whatever field that you want to think about. Mechanical engineers touch that. The chair that you're sitting in, the mechanical engineer probably had a hand in that. The basketball hoops that LeBron James dunks on over people, mechanical engineers had a hand in that. All right. Every single hobby or field that you think you could envision, you have access to like work on that sort of stuff. All right. Usually mechanical engineers coming out of school have very, very good debt to income ratios. What does that mean? The debt to income ratio is how much loan debt you have compared to your salary of your first job. Usually students on average coming out with between $30,000 and $60,000 in loan debt. That's about average. So if you have a salary that's $60,000 and you have $50,000 in loan debt, your debt to income ratio is about somewhere in the 0.8 range. That's very good. Anything less than 2 is very, very good. So if you're in a debt to income ratio less than that, it's good. Finally, high flexibility. I already kind of mentioned this. Work in many engineering and non-engineering fields. Mechanical engineering degree is a highly technical degree sought after not just by companies looking for mechanical engineers, but if you want to get into business, if you want to get into other fields that require technical expertise, you can probably do that. The drawbacks of your undergrad degree. Below average job growth. We just talked about that. Average meaning score. Just talked about that. Most popular engineering major, so you have competition with a lot of other people, right? Not just from MSOE, but from the people all across the world. Generally, a bachelor's mechanical engineering degree, you have lots of responsibility, lots of attention to detail, and a lot of technical background that you have to have day in and day out. Okay, so those are, somewhat drawbacks. Finally, and this is related to what we're going to talk about next, which is more for graduate school, you're kind of limited in your promotion track if you just have a bachelor's degree. And that's not always the case, depending on sort of the company that you go to, but many people might pass you up for promotion in favor of someone that has an advanced degree. Okay. My general comments for your undergrad degree, very good on its own. Obviously, I think the education you're getting here is tremendous. So then the question might be, why would you pursue a grad degree in ME? Okay. Reason number one is that there are many jobs that would require additional level of training. Things like a scientist, a professor. If you want my job, you got to get a PhD. All right. Sadly, but it's truth. R&D manager. Okay. So my point is, let's say you go to work for Boeing. All right. And all of a sudden, Boeing decides, all right, we want a new NACA profile for our 797 that we haven't invented yet. NACA is an acronym for the airfoil, basically, that the wing element is going to be made with, okay? And they're like, boy, I don't know if we should use NACA 0018 or NACA 4937, okay? If you have a bachelor's degree, you're not going to be leading that project, all right? There's going to be someone with a master's degree or a PhD, probably a PhD, that's leading the decision on what sort of airfoil or cross-section of the wing that your aircraft is probably going to have. And that's just an R&D type project that generally goes to people with advanced degrees. So if you want to be working on more interesting stuff, you probably need an advanced degrees, all right? As much as your undergrad degree is valued and respected, advanced degrees in engineering are also highly respected to an even greater degree. It gives you more flexibility to move to other industries, especially those in like business and high technology. So anything energy related, anything stock market related, you can provide some serious value to, let's say, Morgan Stanley if you go and work on mortgages, because you have technical expertise that maybe a lot of those business majors don't really have. Okay. So a lot of expertise there. You'll likely make more money with a grad degree. Just the truth. You can get paid to go to graduate school. More on this in just a second. Either through companies that pay you to go to graduate school, or you can get into a research position in graduate school where a professor at a university basically pays you to do a research project. Okay? So that's some great reasons to do an ME degree. Reasons you might want to avoid an ME degree is because it just costs money to do it, right? Now, maybe many of you have taken out undergrad loans. I imagine that's probably the case. Undergrad loans and grad school loans are different. Undergrad loans, generally you have a deferment on the payment that you have to make until after you graduate. So your interest isn't starting to accrue until usually the day of graduation, sometimes 6 months or a year after you graduate. That is the case for most undergrad loans. Graduate loans are different. Grad plus loans, as they're usually called, this is like the federal program for giving loans, they will start racking up interest immediately and generally have a higher rate. Okay? So if you're going to go to grad school and pay for it yourself, you need to be aware of this. It's not really something that people know and understand and talk about, but it is true. Okay? Grad plus loans, as they're called, you can Google this yourself, have higher interest rates generally, about 7%. It's creeping up from there even a little bit now. Because of COVID, people tend to be going to graduate school. Okay? 7, 8, 9%, not uncommon for grad plus loans, whereas most undergrad student loans are in the range of 3 to 5%. Okay? And these grad plus loans immediate with their interest, right? General cost for an unfunded master's program, about 66,000, as opposed to bachelor's degree for a state school is about 40,000. For MSOE, it's more expensive. All right? There's high opportunity cost also associated with going to graduate school. So this is kind of an economics term, but essentially, if you go for a 2 years master's degree, that's 2 years that you would not have been accruing a typical bachelor level ME salary of about $65,000 a year. If you go for a master's degree, you're basically losing that $130,000 of opportunity cost, even more for a PhD. Okay, so by me getting a PhD, I gave up 6 years of working as a bachelor level, mechanical engineer. I gave up hundreds of thousands of dollars working as a typical engineer to get my PhD. Okay, it's an expensive opportunity cost. Another thing, especially if you go for a PhD, you're going to be spending a lot of your mid-20s working on a tough degree. This is more so for a PhD than a master's degree, but it's the truth. I spent 12 to 14 hours a day sometimes, 6 days, 7 days a week in a lab in my mid-20s. That sucks, okay? There's truth to that. Also, for graduate school, there tends to be high attrition, especially for PhDs. All right. The final point, and I'll show you a few numbers related to this in just a second, is that the increases in your salary from a grad degree in ME might not necessarily offset the cost of the degree itself, especially if you get a PhD. So remember that your undergrad ME degree has such incredible power with it already that it already has the capability of making a lot of money. So getting a master's degree or PhD in engineering doesn't really give you a huge increase in salary. And let me show you some data to back up my point, because data is more powerful than words, despite what some politicians might tell you. Here, this chart is taken from a researcher who was looking at generally the name of this particular paper was the economic contribution of PhDs. This chart tells you everything you need to know in very straightforward fashion. What you're looking at here is the percentage of income you should expect to make over the course of your life, depending on the degree that you get beyond normal high school education. So if you're a man and you get a bachelor's degree in engineering, you can expect to make about 25% over the course of your life more than you would make if you didn't get that degree. Got it? Got it. If you get a master's degree and you're a man, you should expect to make about 33% more money over the course of your life than you would have if you didn't get any degree at all. The interesting bit is that the amount of money you expect to make over the course of your life by getting a PhD degree is about 25% over what you would not have gotten with a PhD. And that's exactly the same as what you would expect to make with your bachelor's degree. And that's because of these things I've already mentioned. The opportunity cost of going to graduate school, and generally you don't make that much more money getting a PhD in engineering than you already would make with the undergraduate degree, which gives you a lot of money making potential already. Okay? So, financially speaking, if money is your only motivation, then you should be getting a master's degree. This is even more pronounced for females. All right? For females, getting a master's degree, you'll expect to make about 48% more money over the course of your life than you would without a master's degree. Compare that to the amount that you'd make if you just get your bachelor's degree is about 32% more than you would make without that degree. Okay? So the point here is that if money is your only motivation, don't get a PhD. For crying out loud. All right? I know this firsthand. I could have made more money if I stopped at my master's degree, went to work at Boeing. I would have had a cush job, a cush life, and I wouldn't have been as interested in the things that I was working on. That's just the reality. The reason I got my PhD is because I wanted to teach, and here I am. I'm teaching, hopefully informing you on why you shouldn't get a PhD. All right? So, if you look at this chart and interpret, your bachelor's degree and master's degree are the best financial options. If money is your only motivation, all right? There you go. Here are the typical options for a grad degree in ME, and I kind of put them into three sort of categories here. Master's degree, no thesis. This is like a glorified undergrad. You will go get a master's degree. You will probably pay for it. You'll take classes for about 2 years, and then you'll walk away and you'll have a master's degree. It's just like glorified undergrad, all right? Then there's a master's degree with a thesis option where you go, you take some amount of additional classes on top of your bachelor's degree, but a majority of your time is spent on a research project that is dictated by some advisor at some university, okay? At full time, this is about 2 years to complete beyond the bachelor's, right? And finally, your other option for an ME grad degree is a PhD, right? Which it might be in the cards for some of you if that's what you're interested in. Here, you're going to attend a lot of classes beyond your bachelor's degree. You have to pass some qualifying exams. You have to write a dissertation of, between 200 and 300, probably closer to 300 pages on a multi-year research project. At full time, this takes about 6 years to do. It's about how long it took me to do it. Right? I graduated with my PhD when I was 28. Now let's talk about thesis versus non-thesis quickly, specifically for the master's degree. So a non-thesis master's, like I said, is just going to some university for a year and a half or 2 years, basically at full time, to get an additional degree. But a lot of those non-thesis options, because you're only taking classes, have like part-time options available, all right? Because you just need to take X amount of classes to get your degree. Online options are also available. You're not reliant on any research, which is nice. Many schools offer this option, so MSOE offers this option. And there are generally high acceptance rates regardless of your grades, okay? Here's my point back to the beginning. If you graduate from MSOE, you can probably find a master's non-thesis program somewhere that will take you, okay? Let's compare that to the thesis masters. All right, thesis, less coursework. You only have to just take a handful of classes usually. But if you write a thesis, you are usually paid by a professor to do the research that you're doing to write your thesis. This includes free tuition, free healthcare, and usually a monthly stipend in the order of $1,500 to $2,000 a month. This is how I made it through graduate school without any loans myself. I was paid by a professor the entire way to do original research. I was given about $1,500 a month to live. I lived in central Illinois, which the cost of living is like dirt. So I, generally had a pretty good life in graduate school financially, right? Your research can be interesting and rewarding, and it's often viewed as more valuable than just the classes-only masters, right? Some drawbacks to each one of these, you can see them listed, but the biggest here is that if you're going to try to go to graduate school to write a thesis and be sponsored by a professor, it's generally very, very competitive, okay? So you have to beat out a lot of other people to become funded by a professor at a university. All right. Your master's thesis versus doctoral degree. Here are similarities and differences. Similarities, additional courses beyond bachelor's degree, both of them have that. You'll work on an original research project. This is if you're getting a master's with a thesis. You're usually paid, and your tuition and healthcare is usually covered for both of these options. Full-time in-person is usually the only way, all right? The differences between the doctoral and the master's thesis, obviously, the timing aspect usually takes about 6 years for the doctoral degree, but you usually have to have higher grades and better GRE scores to get into a doctoral program. You're going to have more courses if you take a doctoral degree, and it'll be a higher GPA requirement. You're going to have to pass some qualifying exams, which you normally wouldn't have to if you just get a master's degree. And you have a lot more requirements for your research. That's why it takes a lot longer, generally, to complete. Okay, so those are differences between master's with thesis and the doctoral degree. If you're going to go to graduate school and either write a thesis or get a PhD where you're writing a dissertation, the most important thing to consider is your advisor. Nothing else. Okay? The research project, yes, whatever you're going to work on for your particular project might be useful, might be interesting to know, but your advisor, if you do not get along with him, you will be miserable and probably drop out, regardless of how much interest you have in your project. Okay? Even if you have a professor that has a lot of money, if you don't get along with them, you don't see eye to eye, or they do some other underhanded stuff like steal your original research, which is horrible, you're not going to have a good day. You're not going to have a good time. You're going to cry a lot. And you're not going to want to go to work. You're not going to want to get out of bed. It's going to be horrible for your mental, for your physical. Don't do it. Okay? There you go. If you're going to get a master's with a thesis or a PhD, got to meet with professors that are going to sponsor you. All right. Timeline for applications. Here they are. I lay them out for all three options, the non-thesis masters, the thesis masters, and the PhD. You can sort of look through these as you want. We're kind of running out of time here. But for all three options, you need to consider taking the GRE now. Okay? If you're a senior right now and you want to go to graduate school in the fall of next year, you need to take the GRE right now. Okay? Then, once you've taken the GRE and you get that out of the way, you're going to start applying to schools. Most of your applications for, regardless of the school you want to go to, probably due in like mid-ish November, though I would say plus or minus a month from that is appropriate. So some might be even due beginning of November, which is only a month from now. Then you'll start getting acceptance letters and all that sort of stuff. That'll happen sort of in the springtime. You might want to visit these schools. You might not. You might just say, all right, I'm going to go to Michigan Tech and be happy. All right, etc. Here's more information about the thesis masters. Looks very similar, except more emphasis on researching the professors you want to work with instead of the schools you want to go to. Same idea here with the doctoral program. It's more about working with a specific professor rather than going to a specific school. So here we get into some of the frequently asked questions, which I'll address now. Does the school I go to for my grad degree matter? This one I get all the time. For non-thesis master's options, yes, this is important, because the only thing associated with your master's degree are the classes that you take in the institution that you went to. A degree from Podunk Tech master's degree is going to be a lot less powerful than a degree from, a non-thesis master's degree from MIT. Okay, it's just the way that it is. But for thesis masters in PhD programs, the name of the school that you go to is not nearly as important as the work that you do for your thesis or your dissertation. There is a very small difference between, let's say, Stanford and UW-Madison when it comes to getting a grad degree if you write a thesis or if you write a dissertation for a PhD. The difference is the work that you worked on and your ability to communicate and provide demonstration of original research. So if you went to Stanford or you went to UW-Madison, in my eyes, you're equal. The next question is, what did you write your thesis on, and is it good? Right? How do I find out what research is being done at a particular school? Visit the websites. That's it. Go see what professors are doing what. If I want to go to grad school for, insert some field here, robotics, material science, physics, etc. Do I need an advanced degree in that? Depends on what you want to do. All right. If so, what should I go to study that field in greater detail? I will tell you, ask around. If you're interested in robotics, go talk to Dr. Farrow. If you're interested in 3D printing, come talk to me. If you're interested in fluids, go talk to Dr. V. All right, like the faculty here actually have a lot of experience with this, so ask them questions. Final comments. My personal advice is that you should get a master's degree. You'll make more money, you'll work on more interesting stuff, and if you graduate from MSOE with an ME degree, you can do it. I promise. I know how smart you guys are. A lot of people might doubt their ability to get a master's degree, but I'm telling you, don't put it on a pedestal. It's the same as undergrad if you get a non-thesis degree, and you can do it, okay? Though if you don't, which is also fine, you still have an amazing degree with lots of value, okay? And I hope I've shown that through like the money or financial side of sort of the beginning of this presentation. So that's it for me, right on time, 2:50. Thanks for listening. I'm happy to answer questions if you have them. Otherwise, thanks for coming. And I'll hang out a little bit if people have questions. What about honorary doctorates? Is there a big pay difference between non-thesis and thesis master's degree? Asked James. I would say that in terms of perception of employers, the non-thesis and thesis masters are, for the most part, equivalent. So I would generally say that that would translate to approximately equal pay. Michael Wyman asks, what about getting into the workforce and getting a company to sponsor? Yeah, that's very common for getting a non-thesis master's, going to work for Komatsu, Boeing, etc., and then having them sponsor you for evening classes, let's say. Adam Abbott, even if we can get a master's somewhere, will it be as difficult and time consuming as getting a bachelor's from MSOE? The answer is yes, probably, if you're going full time. Do grad schools outside the Midwest know of how rigorous MSOE undergrad programs? Yes, they do. Most universities in the Midwest, or most universities across the country, respect MSOE's degree. Okay? Adam says, I'm out. What about getting an MBA? Oh, yeah, I meant to mention that. Sorry, David. Thank you. Let me share my screen one more time for those of you that are still sticking around. One more minute. I meant to mention that. That's on the back end of my slides here. Other options, MBA, law degree, other technical programs. Look at the last slide here if you want answers to that. Okay, there you go, David. That's there. Okay, other questions. Matt Benedict, how do you know if a company will pay for your master's? When you interview with that company, ask them. Mo asks, I've had professional professors share the opinions that their master's degree was extremely more valuable having been in industry for a few years as opposed to getting their degree straight through. Your thoughts? I think there is truth to that, because if you have worked for a company for a short amount of time with, let's say, just a bachelor's degree, you will understand what classes you might want to go back to school for to learn more about. So let's say you start working for a composites company and you are like, okay, well, I need to know how to manufacture composites. You might think about targeting a school that has a lot more classes to offer in their grad program for composite manufacturing, composite mechanics, and so on and so forth. So I think having a few years of experience might be a good idea before you learn exactly what you want to go back to school for. Okay, so that's a good point. It's a signing thing, Benedict. You ask when you go through the hiring process. Yes, that's correct, Michael. Carson asks, what do you think of the MSOE master's program? I honestly don't actually know all that much about it. I would say if you get a classes only master's, you want to go somewhere where you didn't go for your undergraduate degree. And that's specifically because you get a little bit more breadth of knowledge. Like let's say you go down the road to University of Wisconsin, they have more classes that might be geared towards polymer physics and polymer science. Where here, some of our advanced classes would be like the same technical degrees that you might see for your tech electives here as a senior. Okay, so maybe you can get a master's degree by taking advanced, machine component design, HVAC design, all those sorts of things here. But those are things you could have taken as a senior and might already have. So other schools are going to have more specialty type classes that might broaden your depth of knowledge a little bit more. Dylan asks, is there any way I could become an engineering professor with just a master's if it was a teaching degree? I assume that your statistics were having for PhD and ME. So getting a tenure track professor position with a master's degree is hard. I would say it's not impossible, but you are much more likely to get a tenure track professor position if you have a PhD. That doesn't mean you couldn't be a non-tenured instructor, which is what happens at a lot of schools. They're sometimes called professor in practice, or called instructors. I think we call them lecturers or instructors here at MSOE. That position is very common, but you'll not be on a tenure track, which means that you won't have the same job security and ability to be promoted as someone with a PhD. Mo asks, what if my grades aren't good enough? Do I retake classes? If you make it through here with an ME degree, I promise you can get in somewhere with a non-thesis master's program somewhere. It might not be the best school, but you can probably go somewhere to do it. Right? Did you hear back from Dr. Schaefer about our meeting? I did not hear back from Dr. Schaefer. Can a non-thesis master's translate to a doctoral degree? Yes, it usually does. It is one stepping stone towards getting a doctorate if you would like. Other questions? Just to throw a number out there, what sort of GPA do you think I would need to get into a school like Georgia Tech or a school of that level? Are you talking about for a PhD or for a master's degree, Dylan? Dylan wants to get a master's. If you want to get a master's degree at a high level school and you want to write a thesis, you should have a very, very good GPA. Think 3.75 or higher. If you want to get into Georgia Tech to take a classes only master's, your GPA could probably be high 2s and you'd be okay. Michael asks, what about a thesis master's degree? What GPA is considered good? Sort of depends on the school that you go to, but thesis masters are highly competitive, like I mentioned. So if you're going to go somewhere and get paid to do original research by a professor, that's generally a very competitive thing. So if you're going to go to, let's say, Georgia Tech or Wisconsin or Illinois or etc., you should probably set your sights on at least 3.5. Higher than that would be preferred. That's not to say that that's the only consideration that they make. Your GRE score is also important. Your history about like maybe undergrad research or projects you work on as an undergrad are also important. Okay. Levi asks, would you recommend looking for a master's from a Midwest school as MSOE is in the Midwest and there is not a location difference? Dependent on the master's that you go for. If you're going for a non-thesis master's, you can probably go anywhere in the Midwest and get a pretty good experience. If you're looking to write a thesis for your master's degree, then you're going to be beholden by the research projects that are of interest to you. The research projects that interest you might not necessarily be in the Midwest. For instance, if you wanted to study rotorcraft, Northwestern has the best rotorcraft studies that there are in the country. So, or not Northwestern, sorry, Penn State. So you're going to have to go to Penn State, basically, if you want to do a research project on helicopters and rotorcraft. So you have to be a little bit flexible if you're going to write a thesis on where you're going to end up going. Mo says, I didn't know how much I needed this. You're welcome. Are there any benefits for getting multiple master's degrees? Probably. You don't want to get multiple technical master's degrees, let's say that. If you're going to get a master's degree in engineering, it doesn't make a lot of sense then to get a master's degree in, physics. Okay? You're showing technical competence in a very specific field, and you're probably leaning towards that particular field. However, if you are interested in, let's say, business, maybe you get a master's degree in mechanical engineering and a master's in business administration. That's a pretty strong combination. Though I would argue you don't necessarily need the master's in mechanical engineering in that sense, because getting an MBA sort of shows that you're probably more likely to expand on the business side of your education. And you already have a very strong technical background with like an ME degree, and you don't necessarily need another ME grad degree to prove your technical abilities in like an MBA program. Hopefully that makes sense. Other questions? Keep them coming, baby. It's open season. So if all I care about is money, get an MBA in 5-ish years. Well, an MBA is not going to, you could probably get an MBA in like 2 years, okay? I didn't even touch MBAs in this talk because MBAs are complicated. And if you want to know more about MBA, talk to some people in the business school, but MBAs are a dime a dozen now. You can get it from Phoenix College online for, $20,000 or whatever. MBAs are a dime a dozen now, and the power of an MBA is much more predicated on which school you go to. An MBA from Wharton School of Business in UPenn, much more powerful than an MBA from, Michigan Tech, let's say. Okay. CAMS or Red Lion? Neither. How do I go about registering for the GRE? I would just do a Google search, Kyle. Just search GRE, but they usually offer them like every 3 weeks, from what I remember. You can take it electronically. Usually you have to go to some testing center. I'm not sure what the protocols are right now for COVID, but usually you take it at a testing center, you sit in front of a computer screen, and you go at it. You can take the GRE multiple times. So I would advise that if you're not getting the score that you think that you deserve or you think is appropriate for your skill level, take it as many times as you want. There's no penalty for it except for the cost of it. I have an MBA. It will be significantly easier than ME degree. Tim, thank you for that insight. Yes, I would say if you get an ME degree, an MBA is a cakewalk. Jedediah says, if I like to go into leadership, is the master's in engineering management worth it? Absolutely. I would advise you, Jedediah, that you might want to work for a company for a while first and see if they value an advanced degree in engineering management before you just go straight away right out of your undergrad. Okay, continuing. Levi, can you explain the effect of GMAT and GRE scores and how long they are usable for? I don't know about the GMAT, but I can speak to the GRE. I used to tutor the GRE when I lived in Baltimore, and the GRE, if you're going to use the GRE for getting into graduate school, you should shoot for 80th percentile for quantitative. I'd say if you got an ME undergraduate degree, you should be able to achieve 80th percentile for the quantitative portion of the GRE. If you score in the 80th percentile for the ME GRE, you should basically be able to go to whatever graduate school you want. All right, like if you're going to go for a non-thesis option. How long is that good for? I would say a decade is probably an appropriate number. How much does a GRE cost? I don't know that answer right now. I would say probably a couple $100 to take the GRE. Is consideration for master's program different for going into industry first? Like, is there a separate applicant pool for professionals continuing education? Right. I would say that if you're going for a non-thesis option, you're pooled equally with people that have industry experience. I would say if you're going for a thesis, I don't know if having industry experience harms or hurts you. I would say it's probably about a wash, though the person with industry experience might have more ability to sell themselves. James asks, would you recommend getting a master's right away or finding a company to pay for it a few years down the road? I think I'm in the minority here by saying rip the Band-Aid off and do it right away. I think most people would disagree with me, but once you start working for a company and you start making that sweet ME bachelor's degree salary, it can be very hard to walk away from that and go back for a master's degree where you're not getting paid your full salary. You start buying a house, you start getting married, you have kids, salaries become a requirement, and you don't have the flexibility in your life later that you have when you're younger to, let's say, take evening classes or go back full time. So I generally advise Band-Aid, baby. Pull it off, take a year and a half right after your bachelor's degree. While the information is fresh, get it done. Brian asks, which do you think would be more influential in the workplace, master's degree or FEPE? Master's degree by a long shot. Mo asks, if I want to come back to master's after a few years in a job, asking if I want to come back to a master's after a few years into a job, period. Does the consideration for me as an applicant change at all if I've been in industry for a couple of years? No. Take the GRE, apply as normal. You'll write a cover letter probably for your application. You'll explain in your cover letter, I've been working for a short amount of time. I have good industry experience. I know now that I want to go back to graduate school for this reason, this reason, this reason, because it'll help to benefit the company that I'm working for in this way, in this way, in this way. Put together that narrative, make a selling case for yourself. I know you, you're an articulate guy. That's the method. Brady, continuing from James, can I have a job while taking a master's degree through night classes or weekend classes? Yes, that is very common. Usually if you're working for some company, they will ask you to continue working. Okay, so let's pause about this. Let's say you go to work for Harley Davidson and you say, okay, I've been working for a while. Now I want to go back and get a master's degree in the evening. This is very common. You could do this at UWM. They have a master's program for ME evening classes. All right. The way that typically would go is you might work 30 hours per week at your Harley-Davidson job and spend 20 hours per week on your coursework. You may take a reduction in salary from, Harley-Davidson to work at that part-time rate, but they might agree to pay for 75% of your master's degree. There might be some contingencies on how much they're going to give you and how much you might have to agree to work for them after you get that master's degree. Okay? So they might say, all right, we'll pay for your master's degree. You got to take 2 classes in the evening for 3 years. And then after that, you have to work for us for an additional 3 years and we'll pay for it. That's very common. Tracy, when should be the earliest we would have a GRE taken in order to apply for the earliest? You could take it when you're 15. Okay. The latest I'd say is most application deadlines for universities come up mid-November, kind of like I said. If you take a GRE in an electronic sitting, you usually get your feedback immediately or near to immediately on what your score is. So if you want to apply to some school in mid-November, you can probably still take the GRE in early November and make that application deadline, though that would make me nervous as an individual, if you get my drift. Do it now. Now. Other questions? Okay, yay grad school. You got grad school info. If you think of more questions, email me your questions or talk to your, MSOE advisor, because your MSOE advisor went to graduate school and they know about graduate school. All right? So do it. Okay. Bye, guys.